Hi, I'm Kiran Kumar from Nature of Physics. Today topic is maximum height and horizontal range of the projectile. From the projectile concept, part 1 video is already completed, student. Projectile motion, horizontal range, this second part video, student. In the first part video I gave you path of the projectile is a parabola, student, and maximum height, see, this is the initial velocity of the projectile u and it is making an angle theta. So that two-dimension motion, student, in two-dimension motion the initial velocity resolve into two components, that is ux is equal u cos theta horizontal component, uy is equal u sin theta is the vertical component. At maximum height also final velocity is taken as two component, that is vx is equal to u cos theta and horizontal velocity remains constant, student, and vertical velocity at maximum height is equal to 0. Now clearly represented, h is the maximum height, student, r is the horizontal range, and ta is taken as time of ascent, student, and td is taken as time of descent, and total time, that is time of flight, student, time of flight which is equal to sum of the time of ascent plus time of descent, student. So step by step we will discuss. Now maximum height I am going to explain. The greatest vertical displacement of the projectile from where to where, student, here we can write from the O to A point considering. Okay, so the best equation is v square minus u square is equal to as to determination of the maximum height, student. So the given values writing here. So final velocity Vy is equal 0 and initial velocity Ux is equal to, here completely upward direction motion, so that we have to consider Vy, Uy and also Ay, student. So that here this is Uy is equal to U sin theta, student, and next to taken A is equal to minus G upward direction, that is Ay, student, and displacement h is equal to, that is displacement s is equal to h, student. These four values are replacing in this equation, so that we will get Vy square is equal to 0, student, 0 square minus Uy is equal to, we got U sin theta already clearly given in the diagram, student, whole square which is equal to, next 2 into A value is minus G and S is taken as H, student. Okay, continuation step there, minus U square sin square theta which is equal to minus 2G H, student, minus is get cancelled there, and u square sin square theta divided by 2g from RHS side to LHS side which is equal to written as h, student. H is the maximum height, so I can write h max which is equal to u square sin square theta divided by 2g, student. And continuation here, maximum height is depend on the initial velocity and also it is depend on the sin theta, student, that is h max is directly proportional to the square of the sin theta. Theta is the angle of projection, student. Now I can take this is equation number 1, student. And then continuation, second one is time of ascent, considering the time taken by projectile to reach the maximum height, that is from where to where we have to take, student, from the point O to A point we have to consider, student. And continuation here, the best equation from equation of motion is v is equal to u plus at. The values are writing here, vy is equal to 0 and uy is equal to u sin theta, student, and ay is equal to minus g and t is taken as ta, student. So these values are replacing in this equation. We will get continuation here, vy, this is uy and that is ay, student. Values are replacing, vy is equal 0 is equal to u sin theta minus gt, student. Now this is gta which is equal to u sin theta, student. So now I got here Ta which is equal to u sin theta divided by g. Now I can write this is equation number 2, student. So time of ascent is equal time of descent. Already in the vertically upward projection body video given, student, here also time of descent proof is not necessary. We can write time of descent also u sin theta divided by g, student. And continuation step there, that is time of ascent is equal time of descent is equal u sin theta divided by g. Next, time of flight is there, student. In the time of flight we can write sum of the time of ascent and time of descent. So that time of ascent is equal to u sin theta by g, and time of descent also u sin theta divided by g. So total time is from OAB path is time of flight, that is 2u sin theta divided by g, student. Time of ascent or time of descent, time of flight is depend on the initial velocity and also sin theta, student. Now this is, I can write equation number 3, student. Okay, and next one is horizontal range, student. So the horizontal range, the maximum horizontal distance traveled by the projectile during the time of flight, student. So the basic formula for the horizontal range is equal to horizontal initial velocity into time of flight. Velocity is equal displacement by time. Displacement is equal product of velocity and time, student. Clearly R value also I gave you, and continuation derivation there we can write horizontal range R, which is equal to ux is equal to u cos theta, student. Clearly I gave you ux is equal to u cos theta, and time of flight is equal, just now completed, 2u sin theta divided by g, student. Now rearranging the equation, R range which is equal to u into u is u square and 2 sin theta, and next here cos theta is there, divided by denominator only g. So that there is a basic formula, student, that is 2 sin theta into cos theta, which is equal sin 2 theta. So I can write range R is equal to u square sin 2 theta divided by g, student. This is written as equation number 4. Equation 4 represent the horizontal range, student. And continuation, here there is a condition. The condition, if theta is equal to 45 degrees, the range become maximum, student. What will become maximum? Range become maximum. The step I am going to explain here. Theta is equal 45 degrees is replacing in the above equation. R is equal to u square sin 2 into 45, student, divided by g. So this is R, which is equal to u square sin into 2 into 45, that is sin 90 divided by g, student. So horizontal range which is equal to u square sin 90 is equal to 1 divided by g. So now range is maximum, student. The maximum range which is equal to u square divided by g, student. Maximum range which is equal to u square divided by g. This equation is written as equation number 5. Okay, maximum horizontal range which is equal to u square divided by g. Okay, and there is one formula, that is 2 sin theta into cos theta, which is equal to sin 2 theta, student. So this is the maximum height and horizontal range of the projectile. So here first we got the maximum height, after the time of ascent, next time of descent, time of flight, and horizontal range, maximum horizontal range I gave you. Thank you, student.